Well, welcome everybody to the Michigan Azure and M365 user group meeting for September. We've got an exciting lineup for you here today. We're glad that you're joining us, and for those of you who did not join live, we are recording this and we will post it to the user group site. Now, before we get started today, I did want to do what I would call one of my Michigan dad jokes, literally from my father in Michigan. So here's the question for you. Why do Michiganders live the movie The Lion King? Anybody got a guess?
That's a tough one. Don't have a guess on that one.
It's because that's the only time they see the Lions win.
Oh, very good. Very nice.
So for those of you who are from Michigan, the football team is called the Lions. So that was the dad joke. Well, anyway,
that's a very good one, especially after last weekend.
Yes. No. My dad helped me think that one up before last weekend, but it definitely applied here doubly. Yes, like I said, welcome everybody. So, just to kind of reiterate here, we're a small but growing group. We're very excited to have everybody. Our mission here is really to make sure that we have an inclusive environment where everybody can learn more and share information about how they are implementing and using Azure and M365. We're really trying to make sure here that the state of Michigan and everybody in it are really able to use these technologies and are using them to enhance the businesses and the groups and community within the state. And we are, very happy here to share information and bring in expert global, people to speak with us and such to make sure here that we stay cutting edge here in the state. Next slide. We do have a couple of upcoming activities. Just want to make sure that everybody here is aware of other opportunities here to learn and network and to grow. You can find our full schedule at that web address that you see there. But coming up here next month, we'll have Wim back with us again. Oh, too fast. No problem. And he'll be talking about Azure Bastion. And then on November 18th, we've got Victor Rodriguez coming in about monitoring refrigeration trucks using IoT. And then in December, we've got Peter DeTender doing a bunch of stuff here about the container alphabet soup. And then we've already got our speaker lined up here for January. And so we're talking a little bit more about .NET. But as you can see here, we're really mixing our way through here, different topics and different applications based on your input and your comments of what it is that you guys are trying to implement and learn yourself. And so, hopefully here you're finding value out of this, and you will all help us invite a friend for next month as we join up to talk.
And every one of the previous sessions is also, there's a link to that on the website as well. So awesome. If you want to catch up on what we've covered since we started here back in the spring, you can visit the website as well.
And then from our related affiliate groups here, there's another list of events coming up. Just want to make sure here, we've got the back to school activities going on. Lots of good opportunities there for micro learning and such and different topics. MC2MC has a meeting tomorrow. So thank you guys for inviting us to that and make sure everybody's aware of those activities. Another affiliate group here, the Omaha Azure user group. They have an event here tonight, or on tonight and September 30th. They do a bi-weekly activity. And then you can see here we've got a YouTube series on Azure networking.
All right. So we mentioned the Omaha user group in the previous slide. Vaibhav is the organizer of that group. So he's doing double duty today. He's helping us out with presenting as well as his group this evening. And he is a seasoned cloud architect with extensive experience in designing and developing. He, as well as myself, were recently awarded on September 1st the prestigious Microsoft Most Valuable Professional Award in Microsoft Azure. So both of us have kind of went through that process together and the anxiety that creates. So he's a certified Azure Solutions expert, as well as certified in DevOps and security engineer. So and Azure Administrator Associate and Developer Associate. So we'll turn it over to Vaibhav to talk about his topic today, which is Logic Apps. So you should be able to share your screen now, Vaibhav.
Do you see my screen now?
It is there. Thank you.
Just give me a second. Let me set up all my monitors. All right. Hey, everyone. Good morning, good afternoon, good evening, depending upon the time zone you are joining from. This is Vaibhav Gujral. Thanks, Dwayne, for giving me this opportunity to speak on Azure Logic Apps today. Uh, and thanks for the introduction. Just a level setting here, it will be close to 60 minutes session packed with some concepts around Logic Apps and some demos. I would encourage you to keep this meeting interactive and ask any questions if you have between the presentation. If you prefer to post a question on the chat window, that is absolutely fine with me as well. I have chat window opened on my third monitor, and I would be more than happy to hang on for some time after the presentation as well to answer any questions that you might have. With that, let's get started. Quick introduction. Dwayne did cover most part of it. I'm based out of Omaha, Nebraska, and I'm currently working for Kivit as a cloud architect. Just like how Dwayne said, recently awarded Microsoft MVP. I have few certifications on Azure, and there is my contact information listed there. You can follow me on Twitter or connect with me over LinkedIn. With that, let's jump onto agenda and see what we are gonna talk today. So in the next 60 minutes or so, we will see what logic apps are. We'll talk through the different components that make a logic app, like connectors, triggers, actions. We'll see how to create logic apps in Azure Portal in Visual Studio 2019 and Visual Studio Code. And if time permits, we'll also see how to set up automated deployments for logic apps. I'll also talk about Azure, how logic apps can be connected with on-prem systems. Uh, if you have used logic apps in the past or not, I hope you will find this session useful. It would also be helpful to you if you're preparing for your role-based certifications. All right, let's keep the ball rolling. Starting with the very basic for the benefit of people who might not be aware of what a logic app is. Azure Logic Apps is a serverless offering from Microsoft, which is an integration platform as a service, meaning you can schedule, automate, orchestrate tasks, business processes, and workflows using Azure Logic Apps. And why it is serverless is because you only pay for the executions and you don't really pay for the compute, just sitting idle over there. You can design and build scalable solutions for different scenarios like application integration, system integration, EAI, which is enterprise application integration, and several B2B communication scenarios. So some of the common examples where you can find logic apps to be pretty useful could be like order processing scenarios where you might like to process and route orders from one system to another, or you can use logic apps to send email notifications when a specific event happens, or you might also utilize logic apps to perform an action every time someone sends you an email or sends you a new tweet or uploads a new file in your storage account. The possibilities are immense where you can leverage logic apps, and all that is made possible by the number of powerful connectors that are offered for logic app. You name a service and chances are there would already be a built-in connector. For example, for Office 365, Outlook, Azure Functions, Azure Storage, BizTalk, Oracle, SAP, and so on. And just in case if you are trying to integrate logic apps with a service for which you don't see a built-in connector, you can create your own custom connector. Now, there are two distinct ways you can design your Azure Logic apps. You can either design it in a UI-based designer, which is a no-code designer where you can drag and drop or add functions, add different triggers and actions, which we will talk about momentarily. Or you can also utilize code-based designers and design your logic apps in JSON templates. Speaking of deployment options, you have got two different options there. You can directly deploy it through Azure Portal. You can deploy it through Visual Studio. which is built on top of ARM templates. And then certainly since Logic Apps are JSON based, they are built on top of ARM templates. You can deploy them through Azure CLI or Azure PowerShell, or it can also be checked into version control and to enable CI/CD, which we'll talk through towards the end of this presentation. So if you are developing Logic Apps in Visual Studio 2019, ensure that you have Azure Logic App tools for Visual Studio 2019 installed on your local system, because that's what is needed for the local development in Visual Studio 2019. I have provided a link down there if you are willing to get. By default, I believe the extension is installed with Visual Studio 29, but if you, in case you see it missing, you can go to that link and get it installed, or you can also install it within the extensions menu in Visual Studio. Likewise, for Visual Studio Code, it comes with its own extension for working with Azure Logic Apps. I have provided the link down below. Both the extensions for Visual Studio 2019 and Visual Studio Code are pretty powerful, and I will demonstrate what all you can do using both of those. Here is how the UI designer looks like in Azure Portal. It's not very different from what you can see in Visual Studio 2019 as well, and there are very good similarities between the UI designer and Visual Studio Code as well, but this is just to give you a sense of how it looks like in the UI designer. Within the UI designer, it does offers a lot of built-in templates that you can utilize to design your Logic apps. For example, you can utilize template to have built-in built-in triggers and actions for HTTP request and response, for reading your blobs and performing an action, or reading your email and performing an action. There is a variety of that. I'll go through them in a moment in my demo. And this is basically how your Logic app is represented within JSON template. It has primarily 6 different sections. Schema defines the schema for your JSON that you are creating for your Logic app. Content version represents the version. The 4 primary sections that you see down there: parameters, triggers, actions, and outputs is what defines your Logic app, and we are going to talk through each one of them momentarily. So let's look into how Logic apps are composed of. Logic apps have 4 main components to start with. When you create a Logic app, you basically define an activity or a workflow, which is formed out of a couple of things: a trigger and an action. And as the name suggests, you need a trigger to start the execution of a Logic app. And within the execution, what needs to be done is defined in an action. Now, Logic Apps, as I was saying, does supports a variety of connectors. And to be specific, I guess there are 200 plus built-in connectors which are offered for Azure Logic Apps. Those connectors allow you to integrate your Logic app with different services, as I was mentioning in my earlier slides. Each of these connectors does come with their own sets of triggers and actions. So for example, if you use Outlook connector, it comes with its own trigger for new email arrival, which triggers the Logic app whenever you get a new email in your account. And it does supports multiple actions like reading email, sending email, and so on. And as I was mentioning a few minutes earlier, Logic app defines a workflow or an activity, and each activity is formed of triggers and actions. On top of those triggers and actions, you can utilize control flows like if and for each to define your activity workflow, which we'll see in a demo shortly. So to summarize, here is a snapshot of how Logic apps work. Logic apps supports many connectors. Each connector comes with its own triggers and actions. Triggers and actions form an activity or a workflow. You can use control flows to further define your workflows or activities built on top of triggers and actions. And lastly, do remember there are 200 plus built-in connectors before you end up writing your own custom connectors. Do validate if there is a built-in connector already available for your use case. Let's touch upon what is a trigger in a logic app. As the name suggests, I was mentioning in the previous slide as well. It is the first step in any logic app. It usually specifies the event that fires the trigger and starts running your logic app. And actions are the actual executions that take place based on the trigger. There are three kinds of triggers that we have in Logic App, primarily recurrence trigger, polling trigger, and webhook trigger. As the name suggests, recurrence trigger runs on a specific schedule and isn't it tightly associated with a particular service or system. Uh, Polling trigger regularly polls a specific service or system based on the specific schedule, checking for a new or a specific event to be happened. If a new event has happened, the trigger creates and runs a new instance of the logic app. And for example, Azure Service Bus Trigger or Azure Blob Storage Trigger is an example of polling trigger where if you utilize Azure's Blob Storage Trigger, it will keep polling the Azure's Blob Storage, and every time a new blob is uploaded, it automatically triggers your logic app. Lastly, as the name suggests, the webhook trigger exposes a webhook which you can call over REST and trigger your logic app. We'll see all three of those in a demo shortly. Now, it's important to note, I have a different slide on pricing, but do ensure that every time a logic app definition runs, a trigger action or connector executions are metered, meaning that's how logic apps are priced. So every time your trigger or an action or a connector is executed, you are billed for that. And before we jump on to demo, I just wanted to touch upon different types of connectors and the options we have available within Logic Apps. What you're seeing here on the screen is a list of different built-in connectors. It's a small set of connectors that I have picked, but there are many more. As I was saying, there are over 200 built-in connectors to choose from, but I have taken some of the most common ones that you might use. To start with, the primary one is schedule, which helps you run your logic app on a specific schedule. The next one is HTTP. As the name suggests, it lets you run your, it lets your logic app communicates with any endpoint over HTTP or REST. The next one is request, which makes your logic app callable from other applications or services. For example, you can trigger it based on event grid resource events, or you can trigger it on responses to Azure Security Center alerts using the request trigger. Next one is the batch, which processes messages in batches. Azure Functions, Azure APIM, Azure App Services, and Azure Logic Apps are the ones which you can utilize to trigger your Logic Apps based on other Azure services. The last one is Azure Logic Apps can be utilized to create nested Logic Apps. Moving on top of the built-in connectors we just talked about, there are certain control flows that you can utilize within your logic apps to control the workflow. Pretty straightforward. You can define a condition to evaluate the underlying condition and perform different actions. You can perform same actions for every item in an array using for each. You can utilize switch to group your actions into different cases and execute those actions based on certain conditions. You can stop an actively running logic app workflow using terminate action, terminate control workflow. And lastly, you can repeat your actions using until, which is quite similar to for each. Logic apps also provide built-in actions for working with data outputs and their formats. If I speak about data operations, you can perform a variety of operations with your data. You can perform operations with your CSV data. You can perform operations on your JSON data. You can play around with your arrays. You can play around with a variety of different category of data using that data operations. I'll showcase that in my demo shortly. Likewise, if you have date time or timestamps that you want to perform certain operations in your workflow, you can perform those date time operations, which might include like converting your time zone from one time zone to another, fetching current time, fetching future time, or fetching past time, adding or subtracting time, and so on. And lastly, one powerful option that's available out there is variables, which, as the name suggests, lets you define and utilize those variables within your workflow. You can initialize a variable, set a variable. If it's a number-based variable, you can increment that variable or decrement that variable, or you can loop through that variable as well if it's an array variable. Moving on, Logic App does provides these popular standard connectors for automating your workflows with these different category of services or systems. Pretty straightforward. There are connectors available for Azure Service Bus, SQL Server, Outlook, SFTP, Dynamics 365, Salesforce, Twitter, Event Hubs, Event Grids. And again, this is just a snapshot of it. There are many more that's available for your Logic Apps. Lastly, Logic Apps does provide these enterprise connectors for connecting or accessing your enterprise systems, such as your SAP or your IBM mainframe systems, which you can utilize to connect to your enterprise systems. With that, let me quickly jump onto a demo and showcase how you can create a Logic app within Azure Portal and Visual Studio 2019 and Visual Studio Code as well. Let me start with Azure Portal first. If you'll go into Azure Portal under the new menu and look up for Logic app, you can go ahead and choose the subscription, choose a resource group. I already have created certain resource groups for this particular demo, so I will choose one of those. I'll give a name for my Logic app. I'll come later in my slides what is integration service environment, but for now I want my Logic app to be a multi-tenant Logic app, and I just want it to reside in one of the regions. So Central US is my preferred region because that is the nearest region to my location. I'll stick with that. I can enable capturing of my Logic app runtime logs in Log Analytic workspace. I don't have a Log Analytic workspace enabled right now, but you can enable that option through here. So I will go ahead, review it, and create. It will take hardly a few seconds to provision a blank Logic app for me in Azure Portal. You see it's ready. The very first time I visit, I was showing you the snapshot of this particular designer in my slide deck, but for the first time when I open up my Logic app, it gives me an option. I can either go ahead and create a blank Logic app, or I can use an existing template. For example, if I'm looking for HTTP request or response kind of Logic app, or if I want to read my SharePoint and send an email on top of it, whatever my use case is, if I strongly encourage you to go ahead and check out these existing templates if it satisfies your use case. Otherwise, you can also start with a common trigger, or you can start with a Logic app. For this example, let me start with blank Logic app and show you what you can do. So here you can see all different kinds of connectors that you can utilize in your Logic app to build your workflow. Somehow it's not letting me select this. Let me try it again. Here you go. So here you can choose all different category of connectors and utilize for your workflow, as I was talking about, the different built-in standard enterprise and custom connectors. If you have any are listed over here, I'll go ahead and I will, let's say, start with SFTP. So based on that, there is no trigger defined for that. Oops. Something is going wrong. Let me try again. Let me take the existing ones. Strange.
The fun of live demos.
Yeah, so anyways, I knew something might go wrong like that, so I already have some of these demos prepared up front so that at least I can demonstrate the power of Logic Apps. So what I did was I went ahead yesterday and I did created a Logic app with a recursive trigger. So what you see here on the left side is on the menu. As I was mentioning in my slide deck a moment ago, that there are two different types of ways you can design your Logic apps. You can certainly design your Logic apps using, interesting. I want to go in this one. So here you go. So as I was saying, there is a UI-based designer where you can design your workflow, or it automatically translates it into code, or you can also directly go ahead and define your Logic app workflow within JSON. That being said, the example that I'm showing here uses a recurrence trigger which runs every 30 minutes. Every 30 minutes, it goes and looks for all the tweets that people have tweeted with hashtag MSIgnite, and then based on each of those tags or based on each of those tweets, it sends me an email. So for now, I have disabled this particular Logic app because I didn't wanted it to keep running whole night and populating or spamming my mailbox. So I'm going to go ahead and enable it and see if it automatically gets triggered, or otherwise I can go ahead and run it.
The first meal of the day. C'était aussi fatigué ça.
So as you see, my Logic app is running. If I go ahead and see what's happening, it has already found all the tweets. It's looping in. Oops. Interestingly, it failed. Status 429. No idea why it's failing, but to showcase my email, you can see all the different category of tweets that people have been tweeting around MSIgnite in last 30 minutes or so. It has sent me an email, so my Logic app does work. So I'm not sure why it's returning 429. But that being said, it does do a good job, and it hardly took me a couple of minutes to set up this workflow. Now in this, I can go ahead and I can add any But any action, as I was saying, there are certain control workflows that I can utilize here. I can add certain conditions to filter my tweets. I'm already looping in through each of those incoming tweets and sending it to my email. I can utilize switch and filter my tweets based on certain conditions, and I can terminate uh, my workflow if there is certain conditions that take place and so on. Likewise, I can go ahead and add further. I can send those tweets to a REST API or to an app service or to a storage account or service bus. Possibilities are immense, I was saying, and I can do literally whatever my use case demands for. So this is first kind of trigger that I'm trying to show here, where it doesn't need an external system to logic app to trigger. It gets triggered automatically every 30 minutes, goes and looks for all the tweets and sends it over my email. I'm going to disable it so that it doesn't keep spamming my mailbox. And let me go back to my second demo. So in my second demo, I did created a second trigger, which is a storage account blob trigger. What it does is I have connected it to one of my storage accounts to a particular connector, and every time I upload a certain blob in that, it automatically triggers my logic app. And this is, as I was saying, this is kind of a polling trigger. It keeps polling my underlying connector, underlying service, and whenever a new event happens, it automatically triggers my logic app. And this is pretty straightforward demo. Whenever I upload a document or a blob in my storage account, it does sends me an email. So let me go ahead and demonstrate that. I have this storage account in the same resource group within which I have already provisioned my connector. So I'm going to go ahead and upload my picture again. I did upload one of my pictures yesterday, but I'm going to upload my picture once again. And the moment it is uploaded, let's go back and see what's my logic app doing out there. Not yet triggered. Interesting. It's not letting me run the trigger as well.
You're showing that it's not enabled. It looks like Vaibhav.
Oh, my bad. I did disable it overnight. Thanks for pointing it out, Dwayne.
No problem.
Yeah, so I'm going to go ahead and trigger the logic app manually and see what it does. Here it go. It did find out the new document that I uploaded, and it has sent the email. Here is the file that I have uploaded. And if I go to my mailbox, here is what the email that it has sent saying, hey, this is the new file that it has been added to the blob storage. You can utilize it for any kind of workflow though. But what I wanted to show you here is my connector. Here's my connection. Whenever I provision any of my connectors or any trigger or an action, I am connecting to an external service and I'm establishing a connection, which actually goes back and sits in a connection object that you can see in the resource group. So in my logic app, I was reading, polling one of my storage account blobs, and Azure blob connection is the connection which is establishing connectivity within my logic app and the storage account blob. And likewise, I'm able to send email using my Outlook connection. If I go ahead and pull up one of those, you can see the properties for that particular API connection. It says it's connected. That's why it's able to poll my storage account. I can go ahead and I can edit my API connection update, provide the updated storage account connection string or the key to make it work, just in case if the key changes in future. If I go back here, this is
now there, Vaibhav, there's no parameters in which the resources have to be within the same region as the Logic app has
there
been
is no
provisioned,
limitation to that. There's no limitation to that.
Yeah, so the storage account can be in any region and any. It does how about resource group? Any resource group as well could be in a
Any
different
resource group,
as well,
any
right?
storage account. It just needs
Yep.
the connection string to the storage account. In fact, I can connect to Dropbox, or I can connect to OneDrive, or I can connect to any other cloud storage as well. It just needs a connection string, and Logic App does provides those built-in connectors where it will let you provide the connectivity details, and once the connection is established, it can go and connect to those particular services, and there is no limitation that all the resources within Azure should sit in the same resource group as the Logic app. I have placed them in the same resource group for my convenience for this demo, but
yep, I just figured we'd point that out to everybody. It's very intuitive from that standpoint to be able to just very quickly create a workflow, a triggered workflow based on hundreds of different parameters.
Good call out, Dwayne. And my third demo that I wanted to show is on the same lines, where I have created a function app which has a HTTP trigger. I didn't play around with the function much, but it's the default one which it creates to show what it does. If I pass a name, let's say if I pass Dwayne here, it just returns back a message saying, hey Dwayne, this function executed successfully. But it could be any API, anything you can do. But to come to my point, what I'm trying to do in my Logic app here. So I have tried to showcase the HTTP trigger here, where the moment I add a HTTP trigger, it automatically opens up or enables HTTP post URL for me, which I can call anywhere over internet from over REST or HTTP. What I'm doing is, whenever my Logic app receives a request on HTTP, I'm calling my Azure function over HTTP, and I'm passing the incoming body that's coming. How you will see how I'm passing body here when you are creating it. It automatically provides you the dynamic content. For example, if you will see here, I can very easily go ahead and provide the static content, but I can also provide dynamic content. Dynamic content automatically identifies my previous triggers and actions and the output of those. For example, here it's showing the outputs of my trigger, which is an HTTP trigger. It automatically identifies that out of that particular trigger, I can capture the body, the headers, the path parameters, and so on of that. And I also have a parameter defined out here where I'm passing the code or the function key for my function to be called over HTTP. Likewise, if I go ahead and look into my response action, which responds back to my HTTP request for the Logic app, I will show you the dynamic content that it offers. We will see it offers me. Oops, 1 second. It offers both from my trigger as well as HTTP action. So from my action where I'm calling my function, it gives body, header, and status code. And from my trigger, it provides all the dynamic content that I can fetch. On top of it, you can also play around with functions or expressions. You can concat your strings. You can you can perform different types of operations using expressions, like you can compare strings. You can see if there is a substring that exists in the particular string value. You can loop through the arrays. You can fetch the particular array item. You can do lots of things in your expressions. That being said, let me show you how I can call. I am utilizing Postman to show you how my how I can call my HTTP trigger based logic app. So here's the body that I intend to pass. It's a JSON body. I'm gonna call Vim. And here's the response that I get. Let me go ahead and see if it did triggered my logic app or not. Here you see it just got triggered. If I go ahead and see here, it did receive the request and I did pass the value as Vim. It did executed my function app and my function app was executed successfully. It has returned the output, which I have captured and returned it in my response. Pretty straightforward, but at least it shows the power that Logic App comes with. Any questions so far? All right, let me quickly showcase the power of Visual Studio Code and Visual Studio 2019. If you have Azure tools installed on your Visual Studio Code and you have the Logic Apps extension installed on your Visual Studio Code, you can actually go ahead and see all your subscriptions and the different category of resources in your Azure blade here. So if you will go here under Logic App section, here are all the different Logic Apps that I have within my subscription. I can go ahead and see the different types of different runs, that my Logic App was executed at different times. I can see the trigger for my particular Logic App. I was showing this a moment ago where I have it utilizes blob trigger. So here is my trigger. I can see the different versions. So this is a good feature. Every time whenever I update a Logic App, it creates a different version and it lets me go back to the older version whenever I wish to. So if I want to promote an older version to be live one, I can go ahead and simply promote it from here. I can certainly do it from Azure portal. I missed to showcase that. I can go ahead and I can enable or disable my web app from here. I can open my Logic App Designer here and edit the JSON, the code designer here, and edit the JSON directly. I can go ahead and open it in Designer and I can make edits here. Let's say if I go ahead and make it 30 minutes and if I, let me go ahead and make it here. And if I go ahead and save, it automatically asks me if I want to upload my changes or if I want to always upload my changes. The moment I click upload, it automatically captures the changes that I have made in my Logic App definition and it updates my Logic App. Pretty powerful. Likewise, you can go ahead and create a Logic App. You can choose the subscription. You have to go ahead and click, once you click create Logic App here, it pops up this window over here. Go ahead and select your subscription. Go ahead and select, I did chose the wrong subscription, but go ahead and choose the resource group, the location, give a name to your Logic App. My subscription is disabled as I thought so, but let me go ahead and choose the right subscription, which is this one. I will choose this particular resource group, the location. Let's call it test, and you can see it has created a Logic App for me with empty inputs. I can go ahead and work on this JSON template and create my trigger sections. And once I'm done, I can save it and it automatically uploads my Logic App. Likewise, I can go here in Visual Studio 2019. I can go I already have Azure Logic Apps extension installed on my Visual Studio so that I can work on Logic Apps within Visual Studio 2019 environment. But to start with, the template that you have to look for is Azure Resource Group. Once you choose that, give a name for that Logic app. I'm going to choose a different folder. Create. It can not only be just used for Logic apps, but for different variety of other Azure services, because ultimately it creates template that can be deployed to Azure with particular services that you're opting for. For this particular demo, we are going to utilize the template for Logic app. As I was saying, Logic apps are actually built on top of ARM templates. That's why whenever what you are seeing here is a logic app.json and logic app.parameters.json, which is the standard ARM template. In the Logic app template, I can go ahead and see the JSON for my Logic app. Pretty straightforward. As you can see here, this is my complete ARM template with those parameters, and within the resources, you can see it's an empty Logic app for now. And likewise, if there are any parameters that I'm passing to my ARM template, I can specify them here. Why I was stressing on Logic app tools that you should install for Visual Studio is it lets you enable this particular option where you can see your Logic app in Designer and provision it. So the moment you first time open your Logic app in your Designer, it is going to ask your subscription details, your resource group details, and the location where you would like to place your Logic app. And again, pretty much the same experience that you have it in Azure Portal. You can use existing templates, or you can start with a common trigger, or you can start with a blank Logic app. So I already had, oops. I already have another demo that I worked on yesterday. What's up? Interestingly, let me close this project and close that. There you go. I'll go here and open it with Logic app. So it's the same Logic app, that same workflow that I've shown earlier in the Azure portal, creating using an HTTP trigger. Pretty much same, and I have this time created everything in Visual Studio 2019 and not in Azure portal. And once I'm done with my Logic app, I can directly go ahead and deploy it through my Visual Studio 2019. It automatically fetches the subscription and the resource group I have opted while creating my ARM template. I can go ahead and give the parameter values if I have any. I will give one name for my Logic app, and the moment I choose my resource group, this is a subscription, and here's the resource group. Oops. But pretty straightforward experience. The moment you go ahead and click deploy, it picks up your I know what it's doing. It's asking for a secret because I wanted to showcase this with Azure DevOps as well. But let me go ahead and do one thing. Here is the correct solution. I'm sorry, folks. I was showing the wrong project. So this is the correct project that I created yesterday for Visual Studio 2019. What it does is I have a HTTP request where I'm calling a key vault to get the function app secret and passing it in my function app as well. The moment I go ahead and deploy it, pretty much straight forward experience, similar to other services. If you have done any deployments in the past, it picks up the latest logic app definition from my code and goes ahead and deploys it. We'll come back on these shortly. Where is my PowerPoint? My PowerPoint decided to die. Let me open it once again. Do you see my slide deck now?
Yep.
All right, let's touch upon a few other aspects of Logic App. When you are creating your Logic Apps, there are two specific built-in roles which are tied up with Azure Logic Apps. If you intend to provide access control for your users, the two built-in roles are Logic App Contributor and Logic App Owner. The Logic App Contributor lets users manage the Logic Apps, meaning they can modify the Logic Apps. The only thing they cannot do is they cannot grant access to other users to do the same thing. I'm sorry, it says Logic App Owner. It should be Logic App Operator. I think it's a typo I did, but Logic App Operator can read, enable, disable a Logic App, but he cannot modify it. And if you want to prevent accidental modification or deletion of Azure Logic Apps, please utilize Azure Resource Logs. Now, I'll go back to the Logic Apps that I have created to showcase what this means. But if you will remember the HTTP-based trigger that I have created in my Logic App, and I was calling my function app using the function key. If you will notice that that key was visible in the run history, which is certainly not a good or a best practice. So we can actually go ahead and obfuscate our input and output within our Logic Apps. I'll show that in a moment. But just the point to be noted here is that you can secure your run history by obfuscation, and you can hide your secrets in your run history. You can also restrict access to your Logic Apps through IP ranges. For example, you can allow blacklist certain IP address or certain IP ranges from where those Logic Apps can be triggered on or off. You can also specify IP address ranges from where the run history or the other content can be made visible. I will show you in a moment how you can set that. We can also, since Logic Apps are essentially based on ARM templates, they can be version controlled in a repository and can be deployed through pipelines. There are good set of Azure Logic App deployment samples available in that GitHub repo. Please go ahead and check that out. They have some very common use cases for your Logic App deployments. And towards the right, what I'm showing is if you are utilizing Azure DevOps as a repo for your Logic App, then you can utilize the ARM template deployment task, which you can utilize for any ARM deployment within Azure DevOps. It does works like a charm for your Logic App as well. So here is what I was showing. If I go back here and show you my run history, what you would have noticed here is that the secret that I have, the function key, it was all visible in my logic app run history. But I don't want to do that because I'm not sure it might other users might see that secret, or whatever might be the reason I want to obfuscate that secret. So what I'm gonna do is I'll go ahead and go to the settings, and here I can go ahead and secure my inputs and outputs. The moment I go ahead and save this and I go back to Postman and place a request again, let me go back here and see if it was triggered. It was triggered once again, and as you will see, the contents are not shown due to security configuration because they are obfuscated now, which is a kind of very cool feature. If you are looking to allow only certain IP address ranges, go to your workflow settings within your Logic App Blade. For now, for my Logic app, I have allowed any IP address to go ahead and place request to trigger my Logic app. I have not blocked any specific IP addresses, and all IP addresses can go ahead and access my content, but I can very well go ahead and let only other Logic apps to do it if I'm using nested Logic apps, or I can provide specific IP address ranges for triggers as well as my content. I don't want to do that right away, but it's a very good feature you should be aware of. For HTTP-based triggers, you can also utilize Azure Active Directory OAuth authentication and authorizations. For that, you can go ahead and add your own authorization policy here. You can check out different policies here. If I go back to my demo, in this particular demo, I have extended it a little bit. I was showing this particular demo in Visual Studio 2019 a moment ago. So what I'm doing here is I'm reading a secret from one of my key vaults rather than directly hard coding it in my function URL here, and it does fetches it from there. What I can, and if you will go back and see here, it does fetches the secret from the Logic app, from the key vault, and passes it to my function. And certainly I can go ahead and obfuscate my secret value here, but I didn't do it intentionally so that I can show you the correct secret that it is fetching. Moving on, let me go back to my Visual Studio. So I had already created a project which sits in my ADO repository. So I'm going to let me close this project and let me go into this solution. So I have checked in one of my Logic apps into Azure DevOps repo, and I already have set up a pipeline for that, which is pretty straightforward. Let me showcase it to you. This is the pipeline that I created. If I go here, what it does, it fetches the secret from the key vault, it builds my solution that has the Logic app, it publishes the artifact, and it takes the artifact which has my Logic app and deploys it to Azure. And here is where I'm passing my function app secret. What I wanted to show you is passing those parameters, how I'm passing parameters from my ARM template to my Logic app. If I go in here, so as you see, here is my Logic app where I am passing a function app secret parameter. That function app is a secure string type parameter, and I am actually mapping that function app secret parameter to a template, to the overall ARM template parameter called as template function app secret, and that particular parameter is defined here. So essentially what is happening here is I have a template level parameter through which I am assigning value to my Logic app parameter. So what essentially happens is if I go back here, when I'm passing my template function app secret, I am fetching it from the same key vault that I was showing you in the demo. It does fetches it and assigns it to my template parameter, which then again assigns back into the logic app parameter and sets up my logic app. So if I go ahead and run my logic app, it pretty much does the same thing that I was doing manually, but it does help us in establishing continuous integration and continuous delivery for our logic apps. It might take a few seconds or a minute or so for getting an agent and triggering my job. But here is my logic app, which gets deployed directly from ADO. And I did try running it last night. It's pretty straightforward. It fetches the secret from the key vault and updates it here. And it executes my function. The point that I wanted to make here is if we will go here and if we look up into the secret, this was the parameter that I was saying is of secured string type. You can certainly have any other parameter type here and utilize in your workflow. Nothing is blocking you from that. With that, I guess if my pipeline is ready. So it went ahead, it did fetch my key vault secret. It took my code base having the logic app code. It has published the artifact and it goes ahead and it deploys my template having the logic app. So now one of the major drawbacks I have seen in a logic app is that you cannot really test the logic app locally. You have to deploy it every time. So in which case continuous delivery really makes a lot of sense, because then I can push every change I'm making and test it pretty fast in the Azure portal. But again, that's a drawback that I have seen. Again, unlike what I see in Azure Functions, which comes with its own function runtime where I can run and test functions locally. I cannot do that in Logic Apps. All right, moving on fast. I have last 5-10 minutes to wrap up everything. Here are certain set of standard connectors I was showing you while creating a Logic app, which you can use to access data and resources from your on-prem systems. Before you can create a connection to an on-prem systems, you must first download, install, and set up an agent known as on-prem data gateway on a server in your on-prem network. Once that's done, you can create an on-prem data gateway resource in Azure and connect it to your Logic app, and that's it. It establishes the connectivity between your Logic app and your on-prem network. Then you can start utilizing Logic apps to connect to on-prem services like BizTalk servers, file systems, IBM mainframes, and whatsoever. Logic App also provides connectors for building business B2B solutions with your Logic apps. When you create and pay for an integration account, I would encourage you to go ahead and check out how to provision integration account over that link that I have listed there. It's a part of what is known as an enterprise integration pack in Azure. With the integration account, you can create and store B2B artifacts such as trading partners or mappings and whatsoever. To move on, this is pretty much the process that you can follow for your enterprise integration pack or B2B integrations. You go ahead and create an integration account to start with. Once your integration account is created, you go ahead and add your artifacts. Then you create your Logic app, link it to the integration account, and then finally you build your workflow in the Logic app using the artifacts and the connectors. And one very good example, if you have not worked on B2B scenarios before, or if you have, then one good example could be liquid transformations for your JSON and XML schema. If you will work on Logic apps, you will notice Logic app does provide some basic features like parsing JSON and parsing XML, but those are very limited. And in certain B2B scenarios, you might want to utilize liquid transformations for your JSON and XML schema. For such situations, you can utilize enterprise integration pack and integration accounts. And sometimes the logic apps also need access to secured resources such as other virtual machines and other systems and services which are connected to your Azure Virtual Network. To set up that access, you can create an integration service environment, which is, if you have worked in app services, it is quite similar to app service environment. It is an instance of logic app service that uses dedicated resources and runs separately from the multi-tenant logic app service. If you will notice down there, any connectors that are targeted for ISCs have either core or ISC prefixed under them. The advantage you get out of ISC is that you get increased limits on your run duration, storage retention, and other different variety of properties for your logic app connectors. Business continuity or disaster recovery are key requirements for most of the enterprise workloads. The reference architecture that you are seeing on this slide here is an active-active configuration. You have two replicas of your logic app in two different regions. On top of the logic app, you have an Azure load balancer to load balance the incoming request. You can also utilize an APIM or service bus on top of the logic app. And here is an active passive setup. The secondary logic app, as you can see here, is disabled and is only enabled when the primary one goes down. You can check out the reference link I have provided there where this reference architecture has been described for more details. To get richer debugging information about your logic app during runtime, you can also configure your log analytic workspace, as I was mentioning when I was showing you how to create a logic app in Azure portal. You can provision a log analytic workspace there to capture logs from your logic app. You can also extend how to use your logic app diagnostic data using diagnostic settings, not only to log analytics. You can also export it to a storage account and an event hub, similar to like most of the other services. Here's a snapshot of how logic apps are priced at a high level. All the triggers, actions, and connector executions are metered in Azure Logic Apps. The prices per executions are listed over there. Note that the pricing might differ from the ones that I'm showing here on the screen. You should check out the link I have listed there for the updated pricing. Do remember that ISCs and integration accounts are built differently because they are specialized use cases. Here are some of the benefits to conclude Logic Apps presentation with Azure Logic Apps. It lets you build your workflows visually without writing a single line of code. It has first-class support for enterprise integration and B2B scenarios through ISC integration accounts and the variety of connectors that it provides. You can write it once, reuse it often. You can establish continuous delivery on top of your Logic app so that you can deploy it in multiple environments. It is highly extensible, as you have seen already in some of these demos. And it is serverless. You only pay for what you use. You only pay for the executions and not for the compute power just sitting idle over there. Now, if you have used Power Automate in the past, you would have noticed lots of similarities between Logic App and Power Automate. For the benefit of people who don't know about Power Automate, it's a service offering, which is a part of Power Platform. It was formerly called as Microsoft Flow. My Power Automate offers lots of similar features to create and manage workflows, just like Logic Apps. But there are some key differences. For example, Logic Apps are targeted for IT pros and developers, whereas Power Automate is targeted for power users or citizen developers. Power Automate lets you design simple workflows, but if you have advanced use cases like you want to connect with SAP or integration accounts or liquid transformations, Logic App is the way to go. In Power Automate, it just provides a web-based designer, but as you have seen, Azure Logic App does provides a code-based designer as well, where you can design a Logic App using JSON template. Logic Apps are part of Azure ecosystem. Power Automate is part of Office 365, and Logic Apps does support CI/CD. which I have demonstrated like a minute ago. With that, that's pretty much I had for my presentation. And if there are any questions, I guess I can answer them now.
Thank you, Vaibhav. Appreciate it. While you do that, I'm going to switch back to my slides. I haven't seen any questions on the chat, so feel free to unmute yourself if you have any questions. And just to reiterate, this Azure Back to School is an event that I've been doing this month, a community event with lots of Microsoft contributors, MVPs, providing a daily dose of education to everybody. So please visit the link here on the slide, the MC2MC event, which we have one of the organizers of that event on this call here today. I'll be presenting there tomorrow. Vaibhav's Omaha user group link is here for their website. They have an event as well tonight. Another great event to learn more about Azure, and then as well different other events and content that are put out there by myself as well as others in the community. And as we said, we got our website, our Twitter, my personal blog site as well, that I do link some things to the user group from there, as well as myself and Elizabeth's Twitter handle. So welcome to follow us. And I know Vaibhav put his information out there as well. We're usually tweeting and retweeting each other's stuff pretty regularly. So even if you didn't get that earlier, you can find him probably in one of my retweets somewhere along the line. So it doesn't sound like we have any questions. I think you covered it. Great topic on the Logic Apps. One quick point I'd like to say is, like you said, it's very intuitive in terms of what you want to do and how, to get to doing that with the Logic Apps Designer is very easy to get just a simple workflow going, get on there, play with it. It doesn't cost, as you saw from the cost, it costs pennies to run one of them. If you want to get a free Azure account and start playing with it, doesn't cost you anything. So it's nice to
and it's pay as you
nice
go. So
pay as you go.
Only
Exactly.
charge for your execution. So unless you are using ISEs or integration accounts, if you are using plain Logic Apps, because you should be well versed within your MSDN subscriptions as well.
Exactly.